You know how it is, you've poured all this energy into your web app, right? Like our example, TomeStackLite Basic, this Next.js thing.
Mm-hmm.
You get it working perfectly locally. You've wrangled WSL2, Node, the Firebase CLI, Git, VS Code. All that stuff is finally clicking.
Yeah, getting the local setup smooth is its own battle sometimes.
Totally. But then the big question hits. How do you actually get this thing live on Firebase Hosting reliably without it being this like huge manual pain every single time you want to update something?
That's the jump, isn't it? From works on my machine to works for everyone. And yeah, doing it manually.
Oh, nightmare fuel.
Exactly. Building it, then dragging files or running a bunch of commands.
Yeah.
You're just asking for trouble. It takes forever. And it's so easy to like forget a step or upload the wrong thing. Just frustrating.
Right. So that's what we're digging into today, this whole idea of CI/CD, continuous integration, continuous deployment.
The magic automation.
Pretty much. Think of it like an automated assembly line for your code. The second you push a change, boom, this pipeline starts up, builds your app, and shoots it straight to Firebase Hosting. No remembering commands.
Yeah.
It just happens.
Precisely. And we're looking at a really concrete example for this deep dive.
Yeah.
We're talking about taking that Next.js app, TomeStackLite Basic, and automating its deployment to Firebase Hosting using GitHub Actions.
Okay.
And we've got the key piece of source material right here, this file called deploy.yml. That's the instruction manual, basically. It tells GitHub exactly how to run that automated deployment when code gets pushed.
Okay. Deploy.yml, the brains of the operation, you said.
Right.
So where does this file actually live inside a project?
Good question. It's in a specific spot. You'll find a folder named .github right at the root level of your code repository.
The hidden dot folder.
Yep. And inside that, there's another folder called workflows. And that's where your deploy.yml file sits, ready to conduct the orchestra, as you said earlier.
Got it. .github workflows deploy.aml. So if we crack that file open, what's the first thing we're likely going to see?
Probably a line starting with name. So in our example, it's name, deploy basic to Firebase Hosting.
Okay, just a label.
Yeah, but a useful one. It seems simple, but that's the name that shows up in the GitHub Actions interface, you know, on the website.
Right.
Makes it really clear what this particular automated process actually does. Helps you keep track if you have multiple workflows later on.
Makes sense. Like naming your function something useful. Okay, so we've named it. What's next? How does it know when to run?
That's the on section. Crucial part. This tells GitHub Actions what event should, like, kick off this whole process.
The trigger.
Exactly. In our deploy.aml, you'll see on, then push, and under that branches, and then main.
Okay, let me break that down. Push means when code is pushed, and branches.main means only when it's pushed to the main branch.
You got it. So anytime someone pushes code specifically to that main branch in the repository, this whole deployment workflow we're defining just automatically runs.
Wow. Okay, that is slick. You finish your feature, merge it to main, push, and boom, site's updated. Takes away that whole mental checklist.
Totally. Lets you just focus on the code, right?
Yeah.
Deployment becomes like a side effect of finishing your work. Now, right after on, you often see a permissions.block. This is pretty important, especially for security when you're talking to cloud stuff like Firebase.
Right, permissions. Always got to lock things down. What's this doing for us here?
So in this case, we see contents.read and id token.write. Now, connecting the dots. These are specifically needed for the Google Cloud authentication step later on.
Okay.
The id-token.write permission is the key one here. It lets the workflow ask for something called an OpenID Connect token, an OIDC token.
OIDC.
Okay.
Think of it like a temporary super secure passport.
Yeah.
The Google GitHub Action South Action, which we'll see later, uses this short-lived token to prove to Google Cloud, hey, this specific GitHub workflow run is allowed to deploy this app.
Okay. So instead of sticking like a permanent password or secret key right in the workflow file.
Which would be very bad. Right. This OIDC thing is like a temporary pass generated just for this run. That sounds way better.
It is. Much more secure standard practice now. These tokens expire quickly and are tied just to that one workflow execution. So after permissions, we hit the jobs section. What does that suggest?
Jobs. Well, it sounds like where the actual work happens, the tasks.
Spot on. A workflow is made up of one or more jobs. Each job is basically a set of steps that runs on a virtual machine that GitHub provides. They call it a runner.
Okay.
In our deploy.ml, we just have one job, and it's called build and deploy. And just like the workflow, the job itself has a name, too, build and deploy. Again, just a label for the logs makes it easy to see what's happening.
So this build and deploy job runs on a virtual machine, a runner.
Yeah.
Where does that come from? What kind of machine is it?
That's defined by the next line, runs on ubuntu-latest. This tells GitHub Actions, okay, for this job, spin up a fresh virtual machine running the latest version of Ubuntu Linux.
Oh, standard Linux environment.
Exactly. Provides a consistent, predictable place for everything to run, like a clean workshop table every time you start. Avoids those, well, it worked on my computer problems.
Definitely need that consistency.
Hmm.
Okay, then there's an env section right after.
Bang.
Environment variables.
Yep. NVBet lets you set up environment variables that are available to all the steps inside this specific job. And here we've got Firebase CLI experiments, web framework.
Huh, experiments. Sounds experimental.
Well, yeah. And this is kind of interesting. Turns out through, figuring things out the hard way.
Trial and error?
Pretty much. It was found that you need this variable to tell the Firebase CLI, hey, turn on the special newer handling for web frameworks like Next.js. It helps Firebase understand the project structure better during deployment. It's a good example of how setting up CI/CD isn't always just following a perfect recipe. Sometimes you got to dig into logs and try things out.
Right. Real-world problem solving. Sometimes you need these little magic flags. Okay, so we've got our Linux VM. Node's version is maybe set. Oh, wait, not yet. We have the environment set up. Now we get to the actual steps, right? The sequence of tasks.
Exactly. The steps.section. It's an array, a list of all the individual tasks this build and deploy job needs to do, one after the other. First up, .name, checkout repository, and then uses actions checkout at v4. What's that sound like?
Checkout repository. You got to get the code right. And action checkout looks like one of those pre-built things GitHub gives you.
You nailed it. It's fundamental. This step grabs the exact version of your code from your GitHub repo, the commit that actually triggered this workflow, and pulls it down onto that Ubuntu runner environment.
Makes sense. Can't build if you don't have the code.
Right. So now the code's there. What's step 2?
Looks like name. Set up Node.js. Uses .action setup node at v4. And then some with .options.node version 20 and cache.npm.
Okay. So why Node.js?
Well, the app is Next.js, which runs on Node. So this step makes sure the runner has Node installed and specifically version 20, which is what our project needs.
Perfect. And that cache NPM part.
Caching sounds like it saves things to make future runs faster, maybe the downloaded packages.
Exactly right. It enables caching for the no modules directory. So the next time this workflow runs, if your package-lock.json file hasn't changed, it can just reuse all those dependencies it downloaded last time instead of fetching them all again.
Ah, nice. Saves a bunch of time, especially if you have lots of dependencies.
Definitely. Big efficiency gain on repeated deployments. Okay, so code checked out, correct Node.js version installed and ready. What's next, logically?
We need to install all the project-specific packages right, the dependencies.
Precisely. And the step is name, install dependencies with run.npm CI. Now hang on, most people know npm CI. Why npm C here? Any idea?
Continuous integration. I think I remember reading npm C is better for automated builds. It uses the package-lock.json file strictly, ensures you get the exact same versions every time.
Bingo. You're absolutely right. npm-c is tailor-made for these CI/CD pipelines. It does a clean install based only on your package-lock.json. No trying to update versions like npm install might. If your package.json and package-lock.json are somehow out of sync, npm-c actually fails.
Which is good here. You want it to fail if things aren't consistent.
Exactly. Reliability and predictability are key in automation. So npm-c gives us that. Okay, dependencies installed reliably. Now what?
Time to actually build the application itself.
Yep. The step is name, build project with run.npm run build. This command looks familiar to anyone who's worked with Node projects.
Yeah, it just runs the build script defined in your package.json.
Right. And for a Next.js app, that script does all the magic, compiles the React code, optimizes everything for production, generates static pages if needed, bundles it all up, usually puts the result in a .next folder.
Okay, cool. So at this point, sitting on that runner machine, we have the finished, optimized, ready to deploy application build.
Correct. The artifact is ready. Now we just need to get it over to Firebase Hosting.
Which means authentication first, probably.
You got it. Can't talk to Google Cloud without proving who you are. So the next step is name. Authenticate to Google Cloud. It uses that action we mentioned earlier. Google GitHub Actions South at v2.
Okay.
And look at the with.block credentials JSON day secrets. Firebase service account TomeStackLite. This is the secure part.
Right. Secrets means it's pulling from GitHub Secrets, not hard coding anything sensitive here.
Absolutely critical. Firebase Service Account TomeStackLite is the name of a secret you'd configure in your GitHub repository settings. Inside that secret, you paste the JSON key file you download from Google Cloud for a specific service account.
And that service account needs permissions in Google Cloud to deploy to Firebase, I assume.
Precisely. You set that up in Google Cloud's IAM section. So this auth action securely grabs that JSON key from the secret. It never shows up in the logs, and it configures the runner environment so that subsequent tools, like the Firebase CLI in the next step, are already authenticated.
Okay, that makes sense. It's using that secure service account key, hidden away in secrets. Much better than older methods like the Firebase CI token you mentioned.
Yeah, the service account method with a workload identity federation, which this OIDC stuff enables, is definitely the recommended, more robust, and secure way to go now.
Gotcha. Security first. Okay, we're authenticated. Now,
Yeah.
the final push, deploying to Firebase.
The grand finale, the last step, name, deploy to Firebase Hosting. And the command is run. npx firebase-tools at latest, deploy only hosting project TomeStackLite force. Let's pick that command apart.
Okay, yeah. npx firebase-tools at latest. npx runs a package without installing it globally, right?
Yeah.
And at latest means it always grabs the newest version of the Firebase CLI.
Exactly. Ensures you're using the most up-to-date Firebase tooling every time the workflow runs. Good for getting the latest features and bug fixes. Then, the main command, deploy.
Simple enough. But then the flags, only hosting. What's that for?
That tells Firebase, look, I only want to deploy the hosting part of my project right now. Maybe you also use Firebase Functions or Firestore, but this specific push is just for the website files. It targets just the hosting service.
Okay, keeps it focused. And Project TomeStackLite?
Explicitly tells the CLI which Firebase project to deploy to. Super important if you manage multiple projects, like a dev and a prod environment. Prevents accidental deployments to the wrong place.
Good safety measure. And finally, force. The source material said this was added after troubleshooting. What was that about?
Yeah, this is an interesting bit of real-world context. Apparently, the actual deployment of the website files was working fine without force.
Oh, so why add it?
The Firebase CLI, after deploying the files, was trying to do an extra sort of optional thing, set up something called an artifact registry cleanup policy. And for whatever reason in the setup, maybe permissions, maybe something else, that specific secondary step was failing.
Huh. But the website itself was deployed.
Yeah. So rather than get bogged down debugging that non-critical failure related to artifact registry, the pragmatic choice was to add force. It essentially tells the deploy command, hey, push the hosting files through even if some secondary non-essential part of the process throws an error.
Ah, okay. So it forces the main part, deploying hosting,
Yep.
to succeed even if a side task fails.
Yeah,
A practical workaround.
exactly. Sometimes you make those calls in automation to keep things flowing for the main goal.
Wow. Okay, so that's the whole deploy.yml sequence. Check out code, set up Node, install dependencies with npm CI, build the Next.js app, authenticate securely using a service account secret, and finally deploy just the hosting part to the specified Firebase project using force to bypass a minor side issue.
That's the flow.
And once that deployed on IML file is sitting in .github workflows and pushed to GitHub, any subsequent push to main just triggers this whole thing automatically.
Like clockwork. It's your own personal, tireless deployment robot.
Incredible. And like the source mentioned, getting to this working file probably wasn't instant, right? It involved some learning.
Oh, for sure. That reflecting on the journey part is important. Getting CI/CD right often means, digging into failed workflow logs on GitHub Actions, figuring out, oh, I need to enable this specific API in Google Cloud, or, my service account doesn't have the right IAM permission, or understanding weird quirks of the CLI tools, like needing that Firebase experiments flag.
Sounds like a bit of detective work, definitely. But the payoff.
Huge. A fully automated, hands-off deployment saves so much time and prevents so many silly manual errors.
Yeah. So for you listening in, the big takeaway really is just how powerful this automation through CI/CD is. Specifically seeing how GitHub Actions, guided by a file like this, deploy.yml, can just take over that whole repetitive, error-prone deployment task.
Absolutely. We talked about the benefits. Reliability, knowing it runs the same way every time, repeatability, and just the massive time savings.
Right. You get to focus on building cool features, not fiddling with deployment commands. You just push your code and trust that the automation handles the rest in the background.
And that actually leads to a really interesting thought, maybe something for you to chew on after this.
Okay.
Now that you've seen how we automated this specific thing, deploying a web app, what other things in your projects or even just your day-to-day workflow are kind of manual and repetitive right now?
Thinking beyond just websites.
Exactly. Could you use similar automation strategies for, I don't know, running tests, generating reports, updating documentation, syncing data? Where else could you apply these principles of reliability, consistency, and efficiency?
That's a great question. The potential's huge once you start thinking that way. Automation isn't just for deployment. Well, that really wraps up this deep dive nicely.
Yeah.
Hopefully walking through that deploy.yml really clarified how GitHub Actions can automate deployments.
Yeah, hopefully it demystified some of it. And definitely keep thinking about where else automation could help you out. There's always more to streamline.